Hello everyone, welcome to CSC 260 Digital Logic Design tutorial. In this tutorial, we'll discuss decoder and demultiplexer. So what is actually decoder and demultiplexer? Actually, they are MSI circuit. MSI means medium scale integrated circuit. So we'll discuss four type of circuit: decoder, demultiplexer, encoder, and multiplexer. Actually, decoder and demultiplexer are actually same. The only difference between decoder and demultiplexer is uh, we can also pass data or information using demultiplexer. Here is the block diagram of decoder and demultiplexer. We can see its input and its output. So before discussing what is decoder demultiplexer, let's see an example, an application of decoder demultiplexer. Here is a laptop, and we can see each port is connected to a demultiplexer, and we can see that the laptop send the data X. On the other side of the demultiplexer, it is connected to a Bluetooth speaker, fax machine, printer, and a smartphone. We can see the two selector line. So based according to the selector value, we can select D0 line, I mean the Bluetooth speaker. We can choose, we can select the fax machine or printer or the smartphone. Suppose that computer will send data X to fax machine. So when data X will arrive at demultiplexer, it will look at the selector value. So to select the fax machine line, D1 line, this line, we have to give 01. If we give 01, then this line will be activated and X will go to fax machine. If here we give 0 0, then 0 number line will be activated, I mean the Bluetooth speaker, and the data X will pass to the Bluetooth speaker. If here we give 1 1, then D3 line will be activated, I mean the X will go to a smartphone. So you can see that one purpose of demultiplexer is to pass data, and it has multiple output line, and we can also select this multiple output line. We can select one multiple output line at a time, and we can transfer data X to the selected line. So what is actually decoder? Decoder is actually a combinational circuit that has n input line and maximum to the power n output line, and one of this output line will be active based on the input present when the decoder is enabled. So what does it mean? If we can look at the block diagram, then we will understand. Here we can see that it is a decoder, n into 2 to the power n decoder. If a decoder has n bit line or input, then it can have at most, at maximum, 2 to the power n output line. So here is the input line and here's the output line. This is a block diagram of a decoder. We can also convert binary information from n input line to 2 to the power n output lines. So let's see an example. Suppose that here are 4 bulbs: bulb 0, bulb 1, bulb 2, and bulb 3. Now we have to select one bulb at a time, so we can use decoder. It's a 2 into 4 decoder. and here we can see the input, that is X and Y. Now for example, if we want to select bulb 3, then we can give 1 1 here. If we can give if we give 1 1, that means F3 line will be selected, we'll get 1 at F3 line, and bulb 3 will be selected or identified. Actually here 1 1 means, for example, if we give 1 1 in binary, so it is actually 3 in decimal. So if we give 1 1, that F3 line will be activated and bulb 3 will be identified. If we give 1 0, 1 0 in binary indicates 2 in decimal. So we can see that line F2 will be activated and we will get bulb 2. So from this diagram, or from this discussion, we can uh, see its truth table. Here is the truth table. We can see that for a 2 into 4 decoder, we have 4 input combination from 0 to 3. Now we can see that at 0 0, only F0 will be activated, so we get 1 at F0 line, and the other 3 output will be 0. If we give 0 1, then we'll get 1 at F1. If we give 1 0, we'll get 1 at F2, and if we give 1 1, we'll get F3, we'll get 1 at F3. The all other 3 output will be 0. So we can see that we have decoder. Actually decoder has a multiple output line, and we can select one multiple output line based on the input value. So it's a block diagram. Now we can look at its construction. How can we construct this circuit? Actually it is inside of a 2 into 4 decoder. So it is inside of a 2 into 4 decoder. We can see that let's simulate it. If we give 0 0, if we give 0 0, then we will get 1 at F0. I mean only this line will be activated, and this line and the other 3 line will be uh, deactivated. We will get 0. So when we give 0 0, we can see that has the NOT gate, so this 0 will be 1, and this one will be passed to here, and Y is also connected to a NOT gate, so this 0 will be 1 here, and it will go to the AND gate of F0, and we can see that the two input of F0 are 1, so the ultimate output will be 1. Now what about F1? We can see that F1, the one input of F1 is connected to Y, so the value of Y is 0, so the one input of F1 will be 0, and it is an AND gate, so its final output will be 0. Now what about F2? We can see that F2, one input of F2 is connected to X. Now X is 0, so F2 will be 0. What about F3? We can see that F3 is connected to X and Y directly, so F3 will be 0. Now we can see that for a decoder, only one output line will be active at a time. No. So how about a 3 into 8 decoder? For a 3 into 8 decoder, here is the circuit. We can see a truth table. If we give 0 0 0, only O0 will be activated, so we'll get 1 at O0, and the all other 7 output will be 0. So we can see that how can we construct this? We can see that O0 we can see that O0 is connected to C0, B0, A0, and it is an AND gate. So from this truth table we can easily implement it. Now let's consider another combination. For example, O7. O7 will be activated if the input is 1 1 1. So that means O7, the circuit, if we have to connect CBA and take its AND output, the same as 2 into 4 decoder. So from this truth table we can easily build any decoder. Now what about demultiplexer? Actually the difference between demultiplexer and decoder is that we can pass data D. We can see that if the value of S1 and S0 are 0 0 respectively, then we can see that Y0 will be activated, but we can see the value of Y0 will be D instead of 1, because we can see its Boolean function Y0 is D and S1 not and S0 not. So if we give 0 0, Y0 will be activated, and Y0 is also connected to D. So its final value will be depend on D. If D is 0, then Y0 will be 0. If D is 1, then Y0 will be 1. So we can see that based on the selector value, we can pass the data D to any output. I mean D Y1, Y2, Y3 or Y0. So we can actually pass data D using demultiplexer. So demultiplexer is actually identical to a decoder with an enable, and here is the summation. Decoder plus enable plus data, then we can call it a demultiplexer. It has the same function. As decoder. Now we can construct some bigger decoder using a small decoder. For example, we have to build 4 into 16. We have to build 4 into 16 decoder using only 3 into 8 decoder. But we can see that 3 into 8 decoder has 8 output line, but 4 into 16 decoder has 16 output line. If we divide 16 by 8, then the result will be 2. So we need at least 2 3 into 8 decoder. Here is the top decoder, and here is our bottom decoder. Now we can see that a 4 into 16 line has 4 input, but a 3 into 8 decoder has only 3 input. So how can we match or how can we build up this circuit? We can see that here X, Y, Z is connected to top decoder and a bottom decoder, and Another input line W, it is connected to the enable bit of the top decoder and the bottom decoder. So consider a input value for a 4 into 16 line decoder. Consider 0, 1, 1, 0. When we'll give this value in 4 into 16 decoder, for example 0, 1, 1, 0, then D6 line will be activated. Now let's say that which line will activate on this input. So the value of W will be 0 and the value of X, Y, Z will be 1, 1, 0. So as W is 0, we can see here is a NOT gate. So this 0 will be 1 here, and we can see that the enable bit of the top decoder will be 1, so it will activate. But the enable bit of the bottom decoder is 0, so this one will be this one will be active. Now as top decoder is active, we can see the value of XYZ, it is 1, 1, 0. So we can see that from here D6 will be active. So we will get D6, we will get 1 at D6. Now what about 1, 1, 0, 0? Uh, the value of W will be 1. So we can see that as now the W is 1, top decoder will be inactive and bottom decoder will be active, and the value of uh, X, Y, Z are now 1, 0, 0. So we can see from here the fourth line will be activate, and its fourth line will be activate, and above it has 8 line. So actually D12, I mean 4 plus 8, 4 plus 8, as it has 8 output line above it, so D12 will be activated. So we can see that this arrangement will completely work as a 4 into 16 decoder. Here is the explanation. For a 14 into 16 for a 4 into 16 decoder, here is the input combination, and we can see if W is 0, the top decoder is enabled and the other is disabled, and we'll get this term from 0 to 7, so the first 8 term. And if W is 1, if the W is 1, then the enable condition are reversed, so bottom decoder will be active and it will generate 10002 to 111. That means 8 to 15. So we can see the top decoder will cover from 0 to 7 and the bottom decoder will cover from 0 to 15. So we will get actually 16 output line in total. Here is another example. In this circuit we built a 4 into 16 decoder using 2 into 4 decoder. Now as we all know that a 4 into 16 decoder has 4 output line and 2 into 4 decoder has 4 output line, so we need at least 4 decoder. This is first decoder, second decoder, third decoder and fourth decoder. To activate this decoder, I mean at one time only one decoder will be active. So to activate this decoder we also need a fifth decoder, a fifth 2 into 4 decoder. Now let's see that how can it work. Consider first let assign variable to this input line A, B, C, D. So A is the MSB, B, C, and D. So let's consider an arbitrary value, for example 0, 1, 1, 1. You know, in 4 into 16 decoder, if we give 0, 1, 1, 1, then D7 will be active. So let's see what will happen. For 0, 1, 1, 1, the value of A is 0, and the value of B is 1. So 0, 1 means its second line, or its second line will be active, and we can see that its second line is connected to the uh, second decoder. So that means if we give 0, 1, 1, 1, then second decoder will be active. And which line of second decoder will be active? We can see the value of CD, that is 1, 1. So the value of C is 1 and the value of D is 1. So its last line, as it is a 24 decoder, its last line will be active, and we can see that its marking is last line is G7. So we can see that if we give 0, 1, 1, 1, G7 will be active, and now we can see actually D7 will be active. We will get 1 at D7. Now let's consider another example. If we give 1, 1, 1, 0. If we give 1, 1, 1, 0, then if we give then D14 will be active. So let's see how will this work. The value of A and B are now 1, 1. So if we give 1, 1, then its last line will be active, and we can see that the last line is connected to the fourth decoder. You can see the fourth decoder. So only this decoder will be active and the other three decoder will be inactive. And which line of this decoder will active? We can see that the value of CD, that is 1, 0. So we can see that for a 2 into 4 decoder, if we give 1, 0, then third line will be active, that is D14. So we can see that in 4 into 16 decoder, if we give 1, 1, 1, 0, then D14 will be active, and now we can see the actual D14 is now D14 is active. So we'll get 1 at D14. So in this way we can build a bigger decoder using a small decoder. Thanks everyone for watching this tutorial.